Hello, my name is Professor Rame, aka Dean Rame. So, in this lesson, I'm going to be teaching you Chapter 5, Section 7, Modeling with Exponential Equations. So, in this section, we're going to focus on applications involving exponential functions and how to fit an exponential function to data. Exponential models often are useful in solving problems involving change in populations, pollution, temperature, bank savings, drugs in the bloodstream, and even radioactive materials. So, what we're going to be looking at is a compound interest. Compound interest is calculated each period on the original principal and all interest accumulated during past periods. So, although the interest may be stated as a yearly rate, the compounding periods can be yearly a specific number of times per year. So, monthly, quarterly, daily, or continuously. So, if the amount in an account if the interest is compounded annually, can be found using the formula A of t equals p times 1 plus r to the power of t, where A is the amount in the account, P is the principal, R is the interest rate, and T is time and years. Now, if the interest is earned a specific number of times a year, the amount in the account is given by the formula A of t equals P times 1 plus R slash n divided by n to the power of n times t. So, for instance, if the interest is compounded quarterly, then n equals 4. And if the interest is compounded monthly, then n equals 12. So, P still stays as principal, R is still the annual interest rate, and T is still time in years. Now, if the interest is compounded continuously, then the formula for the amount of the account is A to the T, A over T, A to the T equals P times E to the power of R times T, where again, P is still the principal, R is still the interest rate, and T is still time in years. So if we're going to do an example, let's say you're going to invest $10,000. So we have 10,000 and at an interest rate of 5%. So 5% interest. How much money will you have at the end of 20 years if the interest is compounded annually? So our solution would be the principal, which is still 10,000. So P is 10,000. And the interest rate is still 5%. So R is 5% or 0.05. Now we plug it in. So A T equal to 10,000 parentheses 1 plus 5%. I'm going to put 0.05 close parentheses to the power of t. What you do now is you plug it in. So now we have A of t equal to 10,000 parentheses. Now you added 1 plus 0.05 or 5%. So now you have 1.05 close parentheses to the power of t. Now, we're talking about 20 years. So, T, you have to remember, T is time. So, 20 years is T. So, after 20 years, so A of 20 equal to 10,000 times 1.05 to the power of 20, because T is 20. Now, simplify that, and you'll get $26,532.98 over a 20-year period if the interest is compounded at 5%. Now let's do this in a monthly. So if the principal is still 10,000 for P and the interest rate still, so R is still 5%, and the interest is earned 12 times a year. So there's 12 months in a year. So what we do is replace n with 12. So plug it in. A of t equals 10,000 times 1 plus 5%, so 0.05, divided by 12 to the power of t times 12. Now, what we do is, again, do the parentheses. So solve the parentheses. So a of t is equal to 10,000 times 1, bear with me here, 1.004166667, close parentheses, to the power of 12t. Now, after 20 years, so a to the time of 20 years is equal to 10,000, to write this a little bit smaller, times this again, so 1.004166667, that's a mouthful, to the power of 12 times 20. Now, when you simplify this, your answer should be $27,126.40. That's how much you'll accumulate. That's how much you'll earn 12 times a year. All right. So now, if we're going to do this continuously, the principal again still at 10,000. So P is still 10,000. R still 5%. 5% or 0.05. Now the solution to this is plug it in to this formula. A of t is equal to 10,000 times e to the power of 5%, so 0.05 t. T. Now, after 20 years, so all you do is you plug in 20 to the t. So A 20 to t 20 equals 10,000 times e, or 10,000 e, I'm sorry, 10,000 e to the power of 0.05 times 20. Simplify that, you'll get $27,182.82. Now, how much would you need to invest to get $15,000 in 10 years at a 3% interest rate compounded quarterly? So, if the interest rate is 3%, so the interest, let's actually make this on a bigger screen, blank, so don't get confused. So if the interest rate is 3% or 0.03, and n equals 4, so that's quarterly. So there's, speaking in business terms, quarterly is always 4. So n equals 4, and t is years. So t is equal to years. T is equal to years, but t is 10. So now we're trying to find the principal. So P, we're trying to find P when A is equal to 15,000. So the amount, so A is equal to $15,000. Now, what we do is we plug it into the formula. So A T is equal to P times 1 plus 3%, so 0.3, 0.03, divided by 4 to the power of 4 times 10. Now what we do is we plug in 15,000 for the amount. So 15,000 equal to P times 1.0075, and then you multiply 4 times 10, which you get 40, and then you added the 1 plus 3%, and then you divided it by 4. So that left you with 1.0075 to the 40th power. Now what you do is you plug in these powers, so now you're left with 15,000 equal to P times 1.34835, close parentheses. So P, so now you divide by both sides. You divide 1.3485 by 15,000. So you're left with P equals 111,000. No, excuse me. It's $11,124.72. Now, let's talk about other exponential applications. So we can include growth and decay. So let's look at several examples where the y-intercept must be found as well as the base of the exponential equation when the y-intercept is unknown. So we use a system of equations and the substitution method to follow the substitution method to solve for the y-intercept and the base. So an example would be, let's say during the 1980s, the population, that just so we can have a blank screen. Let's say during the 1980s, the population of a certain city rose to 205,000 people in 1989. So the population of the city was 127,000 in 1983. So in 1989, we had a population of 205,000 people. In 1983, we had a population of 127,000 people. So what we have to do is we have to find an equation for the population of the city at any time, so t, where t is a number of years after 1980. So the solution would be, we do not know the population of 1980. So t is right now equal to 0 for 1980. We know the population in 1983 was 127,000. So t for equal 3. And then for population of 1989, we know that it was 205,000. So t for 9. Now, the general equation is P of t is equal to A times B to the power of t. So the point 3, let's write that right here. So the point 3, 127,000 gives 127,000. So it gives us 127,000 equal to A times B, close parentheses, to the power of 3. And then same goes for the what's it called, the points of the 9, 205,000, close parentheses, and that gives us 205,000 equal to A to B to the 9th. This system of equations, which can be solved using the substitution method. So solving the first equation for A. So A equals 127,000 over B to the third. Horrible 3. So substituting into the second equation for A, so we have 127,000. So what we do is we substitute A. So what we do is 205,000 is equal to 127,000 over B to the third times B, that looks like a minus, times B to the ninth. Simplifying, we get left with 205,000 is equal to 127,000 B to the sixth. Now, dividing by both sides by 127,000. So if we divide by 127,000, we are left with 1.61417 equal to B to the sixth. That is a horrible equal sign. I apologize for that. And that is one bad 6. Now we raise both sides to the 1 over 6 power. So now we're left with B is equal to 1.083. Now solving for A is equal to 127,000 over B to the third equal to 127,000 over 1.083 close parentheses to the third power equal to 9981. Now, sure. Okay, so now the equation for the population of the city is P to the T is now equal to 99,981 times 1.083 close parentheses to the power of T.